Hey everyone, and welcome. Today we're going to talk about one of the biggest headaches in software development, actually getting the brilliant code from your machine out to your users, quickly and safely. We're going to see how a tool like Jenkins can build a completely automated pipeline for a Java project, turning what's often a really complex process into a simple, hands-off operation.
Just picture this for a second. You finish up a new feature, you push your code, and you go grab a coffee. By the time you get back to your desk, that code has already been automatically built, it's been rigorously tested, and it's been deployed live for your users to see. And look, that's not some far-off dream. It's the reality of a well-built CI/CD pipeline.
So, that's exactly what we're going to do. We're going to follow a piece of code on its incredible journey. We'll see how an automation server like Jenkins creates this reliable, high-speed assembly line for software and how it transforms a manual, error-prone process into something you can actually trust. So, you might be asking, why is automation such a big deal? Well, because the old way of doing things, manually building, testing, and deploying, is just slow, it's repetitive, and honestly, it's incredibly risky. One single mistyped command or a forgotten step can bring your entire application down. It's a process that is just begging to be automated. A better way really starts right here with something called continuous integration, or CI. The idea is so simple, but it's also revolutionary. Every single time a developer commits a change, an automated process kicks in instantly to build the project and run all the tests. It's kind of like having a robotic quality checker that never sleeps, making sure your codebase is always healthy. And from there, the next logical step is continuous deployment, or CD. The logic is pretty straightforward. If our automated tests tell us the code is solid, why should a human have to push a button to release it? CD just automates that final step, deploying every validated change directly to production. This is the real secret behind those teams that release new features multiple times a day. And the tool that orchestrates this whole dance? Well, that's Jenkins. The best way to think of it is like that high-tech assembly line for your code. It's the open-source automation server that handles every single step we need to get from a fresh commit to a live deployment, all without anyone having to lift a finger. Okay, so theory is great, but what does this assembly line actually look like in practice? Let's follow a piece of code on its automated journey through a real-world pipeline for a Java application.
So here's the game plan. It all kicks off with Jenkins pulling the latest code from GitHub. From there, it uses a tool called Maven to build the application. Next up, and this is crucial, it runs our tests as a quality gate. Then, it packages everything into a portable Docker container, pushes that container to a central registry, and finally, deploys it to a live server. Now here's the really brilliant part. This entire, complex workflow isn't configured by clicking a bunch of buttons in some UI. Nope, it's all defined as code right inside a single file, the Jenkinsfile. And what that means is our pipeline is version controlled, it's reviewable, and it's repeatable, just like our application code.
Let's actually look at the code. Our very first stage, checkout code, is super simple. It just tells Jenkins to use Git to pull the latest source code from our GitHub repository. This right here is the starting pistol for the entire pipeline. Next in the build stage, Jenkins runs a simple shell command, mvn clean package. For any Java developers out there, this is bread and butter. It's the command that compiles our code and packages it all up into a runnable application file. And here's our automated safety net. The test stage runs mvn test to execute every single automated test we have. This is, without a doubt, the most critical quality gate. If even one test fails, the pipeline stops dead in its tracks, preventing a bug from ever getting close to our users. So, with our code built and tested, we now need to package it up for deployment. This stage uses Docker to build a standardized, self-contained image of our application, including all its dependencies. We then push this image to a registry like Docker Hub, which makes it universally available for deployment anywhere. And here it is, the final step that makes this whole thing worthwhile. The deploy stage runs a simple Docker run command. This pulls our brand new image from the registry and starts it on the server. And just like that, our new code is live.
So how does Jenkins know how to talk to Git, or run Maven, or build Docker containers? Well, the truth is, it doesn't. Not right out of the box. Its real power comes from this massive ecosystem of plugins that basically teach it how to do all these amazing things.
See, our pipeline relies on a specific toolkit of these plugins. The Git and Maven plugins handle the code and build stages we saw. The Docker plugin lets us work with containers. The core pipeline plugin is what lets us write that Jenkins file in the first place. And the JUnit plugin gives us these really clean visual reports on our test results.
This all sounds great, right? But what actually kicks it off? We don't want to be manually clicking a build button every time. The trigger is something called a GitHub webhook. It's just a simple setting in your GitHub repository that sends a little notification to your Jenkins server every time new code is pushed. That notification is the signal for Jenkins to start the entire pipeline.
All right, so now that we have the mechanics down, let's talk a little bit about building better pipelines and also take a quick look at some alternatives to Jenkins.
As you start building your own pipelines, definitely keep these tips in mind. Treat your Jenkins file like code. Seriously, put it in version control. Keep your stages simple and modular, and most importantly, never ever commit secrets like passwords directly into your file. Use Jenkins' built-in credential management to keep them safe.
Now, Jenkins is a powerhouse for sure, but it's not the only tool out there. Competitors like GitLab CI, GitHub Actions, and Circle CI offer these deeply integrated, often cloud-based solutions. And the biggest difference you'll probably notice? Most of these modern alternatives have standardized on using YAML for defining their pipelines.
It really boils down to two different philosophies. Jenkins is the classic, highly customizable engine powered by a massive library of plugins that lets you connect to pretty much anything. The modern alternatives trade some of that customization for a simpler, YAML-based configuration that's really tightly integrated with their platform.
So let's bring this all back together. Why go through the effort of setting all of this up? I mean, what is the ultimate benefit of adopting this kind of workflow?
The result of all this is a really fundamental shift in how you work. You're replacing a manual, often stressful release process with a system that is fully automated, completely reliable, and is continuously delivering value to your users. It's about shipping better software, faster, and with way more confidence. And that leaves us with one final thought. You know, automation isn't an all-or-nothing game. You can absolutely start small. Automate your build process first, then maybe automate your tests, then your deployment. So take a look at your workflow, find the most painful, most repetitive part, and ask yourself, what will you automate first?